Hello and welcome to the channel of Sigma Plus Industrial Solutions. In that video, we will continue the discussion about the Multi-Vari Chart. And today we will take a working example about a workshop that produce electrical control panels. And the team is facing some difficulties to deliver the products to the customer on time. They think that the problem might be related to the time estimation, but through the multivary, we will see what were the root causes of the time variation in the production that was leading to the delay of delivery. In the previous video, we have introduced the multi-vari chart as an important statistical tool to define the root causes of the variation. And as all of us know that in Six Sigma, it's so important to know the root causes of the variations because the goal of the Lean Six Sigma is to remove or to reduce the variations that are caused by the defects. But the most important point is to optimize the time and the efforts of the team to find the real root causes and removing the variations. We have also highlighted about the type of the causes. It could be inherent or assignable causes of the variation. We have mentioned that the assignable causes can be easily remarked and removed. And for the inherent causes, we have highlighted it's so difficult that we can remove all the inherent causes of the variation. Today, we will take that working example and we will solve it to the Minitab software. Don't go away. Okay, so the work example here says that a manager of a workshop which produce electrical control panels observed that there is a time variation in delivering the products to the customers, which might affect the reputation of the workshop in front of the customers. So there is a meeting between the manager and the team working on that workshop. The boss looks a little bit upset and he's highlighting to his team that he's paying penalties because they are not able to deliver the products on time. And the team think that there might be some problems related with the time estimation. But is it true? Do you think it could be the real root cause of that? Or there could be some kind of variations in the time consumed in the production, but in fact they don't know where is the main contribution factor of that variation, so they will be capable to improve the production and faster the delivery to the customer. So the example highlight that there is two different type of design A and design B, and the manager he wants to make to conduct a multivariate analysis to find out the sources of the variations and to fix it. The workshop is working as a mass production of two main products, the North and the South design, which is design A and design B, and has three different technicians in the assembly who are completely responsible to produce those both products. So what is the goal? The goal here is to study the sources of the variation in the production cycle time. So the production cycle time is the main factor related to the delivery, the on-time delivery to the customer. So that's why it is considered to be the output, right? And this variation can exist due to the different type of product design. And there is also a second doubt about the worker skills. So it could be there are two contribution factors on the production cycle time. And when we speak in the Six Sigma about the contribution factor, we used to call them the X factors, right? Because the philosophy of the Lean Six Sigma, if we recall back the our initial studies, Y is a function on X, and X are the contribution factors on the output. So what we want to study here is the effect of the type of the design and the worker skills on the production cycle time to see if there is really an effect of those factors on the production cycle time or no. So the goal of that exercise will be to study the effect of the design individually on the production cycle time, which we want to see if there is any complication in the design or there is some special causes leading to have longer time in the production due to design complication. We want to study the effect of the technician individually on the production cycle time. And we want to study the effects of the panels individually on the production cycle time. And we want also to study the effect of the design and the technician, the union effect or the combination, the combined effect of the design and the technician on the production cycle time, and also the union effect of the design of the parts. So as you can see, Minitab is a very strong software that gave us a strong statistical description for the contribution factors which has the most effect on the output, right? So the first thing that we need to do when we work with the multivary is that we need, first of all, to construct the hierarchical clustering, showing the two major factors that are affecting on the production cycle time or the output. So we have the design, which is design A and design B, the north and the south design, and we have the name of the three technicians who are working with the both design. And the second step that we have created a data collection plan where you can see it's in a tabulated form, consists of three main columns. The first one is the design type. The second one is the technician name. And the third one is the production cycle time that is consumed by the technician. So we will have to put to give those template to the operators in the production floor, so they start to record the time that they have consumed in each panel. So assume that we have already received the report from the production file after a certain time, and now we are ready to start the first steps in the multi-vari chart. But just by looking to the numbers that we have, and that's the beauty of the data collection in the Six Sigma, to try to have understand what the data is telling you. So as an initial interpretation for the data, for example, if we look to the North design panel and the time consumed by the technicians, what are the initial conclusion that we can see here? So if we look to the first graph is showing the time consumed per each technician for the North design panel. So the black line is Steve, the red one is Adam, and the blue one is Ahmed. Okay, so what can we see here? Each technician has an internal variation, right? And from the previous session when we were discussing about that, if we assume that each worker is one sample, do you remember what did we used to call this kind of variation? We used to call it the within variation, or it's also called the positional variation. Okay, so that's the first remark that we can see from the figure. But what could be the second remark here? We can see that in certain situations, there is a very close performance between Adam and Ahmed, but in certain panels, there had been some high variation. Okay, but we can see also that Steve is slower than Adam and Ahmed. Steve, as you can see, he has a variation in his time performance, which is varying approximately between 43 hours to 47 hours. But if we look to Adam, Adam has a variation in the time approximately between, we can say, 39 hours to 45 hours approximately. And Ahmed has an internal variation for the time that he's consuming from 34 hours to about, we can say, 38 or we can say 42 hours. Okay, so What can this figure also is telling me is it can tells me that there is a lack of standardization between the workers. What does it mean? It means that it might be that all the workers, the three workers are working in a production without having a clear standardization method to fix the electrical equipment and wiring termination. And that's also one of the reasons that could lead to have a high remarkable variation in between the workers. So as a first impression, we can see that there is a lack of standardization in the skills of the workers in the production line. Okay, the right figure here is the plot. If we can as we can take the average performance of all the technicians for each panel. Okay, so the yellow row is plotted here in that graph and is showing also the within variation of the team as one team here, but that is also showing to us that there is an internal variation. But I am much more interested with the left figure, which is have given me a lot of messages, a lot of indications about the lack of standardization, right? But again, and we can do the same thing also for the south design, okay? But if we look to the right figure for the south design, what can you see? Again, there is also the same definition of the positional variation, but look to the variance, the average variance of the within sample for the south design compared with the north design. What can you see? You can see that the south design has a higher variation compared with the north design. What does it mean? It means that there could be some kind of complication in a south design, that the workers are not well trained or not well familiar with some new technologies that could be existing in a south design. So what could be the solution? Simply we get to provide some kind of training to the workers, or removing any kind of complications or any complicated solutions that could lead to defect, right? So this is a point from the designer that has to take in consideration to simplify the design to the worker. So we make sure that the worker is 100% capable to do the work on time and on quality. Okay, now let's go now to the first step in the Minitab solution. So the first thing that we need to do is to arrange the data in a tabulated form. So as you can see, what we have done, we have tabulated the data in four main columns: the design number, or the, sorry, here should be, it's a small mistake, the panel number, and here is the column related to the worker. And then we have the type of the design. Is it a north or it's a south design? And here is the cycle time consumed by each technician. Okay, now I think this is the we are ready. I prefer to go directly now to the Minitab. Just I need to copy the tabulated form for the time of the activities that had been updated from the technicians, so we can paste it on the Minitab. Okay, just please give me a minute. Okay, so now I think I can drag the Minitab. I will make a new project. Okay, now I have already my table prepared, and I had already copy pasted from Excel. I will just adjust, correct the titles. Here is the panel number, and here is the design type. Okay, now as we can see, uh, the Minitab is really a friendly software, and but the most important point that you choose the right tools, because that's the big trick in the Minitab, that if you use the wrong tools, that it will give you completely wrong conclusion, right? So To do the multivary or to conclude or to construct the multivary chart, you have to go to the quality tools and then you go to the multivary charts. Okay, you click on the multivary chart. So the response or the output is the cycle time of the production. And then the factor one, I want to know the effect of the workers, of the technicians, right, on the cycle time. So I will click on the worker. Okay, I will click OK, and let's see what did the Minitab give me. So this is the graph that Minitab had given to me, and as you can see, this is the y-axis is the production cycle time in hours, and the x-axis are the technicians. So you can see that the average cycle time performed by Adam is about approximately 47 hours, while Ahmed is consuming approximately about 45 hours, and Steve is consuming about 52 and a half hours. So that is also uh, uh, um, another evidence that we spoke about the lack of standardization between the workers. We can see also that Steve is the slowest technician in producing the panels, and this could be because Steve is a junior technician or recently joined the production, so that's why he might be not so familiar with the running activities. So again, we can see here that there is a lack of standardization in producing the panel between the workers. So as an initial action that we can do is to provide training to the workers, right? Now I will just save the graph in our database because we need it after finishing the Minitab, so we can make the conclusion. Okay, so we have studied the first factor, the effect of the worker on the production cycle time. Now, if I want to study the effect of the design, so I will remove the worker and I put the design type, and let's see. Ah, so you can see that here the Minitab is telling me that the average time consumed by the workers in the production line for the south design is approximately 54 hours compared with 42 hours for the north design. So we have a big difference, a big variation of approximately 12 hours between the both design. Okay, so we have again a lack of standardization. So what could be the potential causes here? The design could be complicated. The workers could be not so familiar with all the technology solutions provided in that control panel. Some designs could contain some kind of softwares or technology that the even the expert technicians could be not familiar with it. So it's always good that before that we start a new design, that we make sure that the technician are fully aware about that design and understand 100% how this product will this design will be produced. And if we see that there is a lack of understand, there is some difficulties, that it is our responsibilities to provide training to the people, right? So in this case, we can make sure that we can standardize the time of the production. And in some cases, sometimes even the design could contain much more quantity of electrical parts which are not required. So I believe there are always opportunities of smart solutions, right, to reduce the number of the parts and the equipment that are installed in the control panels. Okay, so we have seen now the effect of the panels, of the design panel on the production cycle time. Again, I will take this graph and save it in our database. Now, we want to understand, to see the effect of the workers and the design on the production cycle time. So we'll go again to the multi-vari chart, and I will select the worker, and then I will select the design type and I click OK. And now, okay, so maybe here I made a small mistake and I will correct myself. Now, as you can see, when I select here, it's what it's showing to me here. It's showing to me you can see the y-axis is the cycle time and the x-axis is the design type, the north and the south design. And you have the 3 points, which are the time consumed by the three technicians that we have, with the average cycle time for the three technicians. And as you can see that the south design is consuming longer time, much more longer time, which was about approximately the 52 hours compared with about 42 hours in the north design. So this is the union effect of the design and the type of the design and the workers on the production cycle time. Now, I just want to highlight to you a small point, which is, let me first save that graph. Now, if I return back to the same study, I will go to the multi-vari chart. Now, instead of starting with the worker, I will write the design type, and the second factor will be the worker. I click OK, and what you can see here, it is showing to me now in the y-axis the cycle time, and for the in the production, and the x-axis is showing to me the workers, right? So you can see here that this is the range time consumed by each technician for the both designs, the south and the north design. So Adam is consuming averagely between the 41, 42 hours to approximately 52 hours. And Steve is consuming approximately about 46 to 59 hours. So again, you can see on the dotted line is the average time consumed between the three technicians. And again, we can see that there is a remarkable variance between the skills of the workers to produce the electrical panels, right? So again, I will just copy that graph and save it, because again, I will need it so we can plot it in our PowerPoint presentation. Now, I believe that we finished from the Minitab, so we can go back to the our PowerPoint, and we can start now to plot the graphs that we got from the Minitab. So that was the effect of the workers on the production cycle time. And then I can plot again this graph here, just a minute. And that was the effect of the design type on the production cycle time. And here was the union effect of the workers and the design type on the production cycle time. Now, don't forget that when you finish plotting the graphs of the multivary, that you plot your statistical statement. So such of statistical statement supported with the figures that you have concluded from the Minitab will support you and the team to take the right decision and save the time to find and investigate the root causes of the delay of the delivery. So at the end of that presentation, I would like to thank you for your good listening and watching.